Well, a very good morning, good afternoon, and good evening to all of you joining us today, wherever you are in the world. And a very warm welcome to the Energy Institute policy debate. And today we're focusing on the development of low carbon clusters here in the UK. We've got nearly 400 registered participants, so I'm delighted to see such a huge level of interest in this session today. My name's Nick Waith. I'm the Chief Executive of the Energy Institute. For those of you who maybe don't know the Energy Institute terribly well, we are an independent network of energy professionals around the world, spanning the entirety of the energy system, and our role, as well as development of our many members around the world, is to convene and facilitate debate and bring together expertise across the industry to help people better understand, manage, and value energy. So I'm really excited to have three fantastic guests today who will be speaking to you soon. We have Professor Mercedes Maroto-Valer, Director of the UK Industrial Decarbonisation Research and Innovation Centre, otherwise known as IDRIC. Julia Pike, who is the Director of Financing and Economic Regulation at Sizewell C, part of EDF Energy, and Dan Sadler, who is the UK Low Carbon Director for Equinor. And I think this is going to be a really interesting session. Professor Mercedes is going to set out a high-level overview of what we mean by low carbon clusters and talk sort of around the whole activity set that's going on in that space. And then we're going to hear from two people from industry, obviously. Julia's background is more on the electron side, and Dan comes perhaps more from the molecule side. And I think that's really interesting because the space we're going into now is a world where the convergence of electrons and molecules is likely to become more common, particularly as we think about new energy vectors like hydrogen, that will see maybe electrons being made into hydrogen and then back into electrons. So I'll introduce each of the speakers formally when they come on to speak. Just a few housekeeping points, if I may. I'd just advise you that all of your microphones are turned off, and although we'd love to see you all, your cameras are turned off just to manage the bandwidth of the event. We are recording today's event, and it will be linked and sent out to all of you after the event, as well as put in on the EI's public YouTube event. So we are not operating under Chatham House rule. Everything today will become a matter of public record. And then very finally, we're after each of the presenters has spoken, we're looking forward to having a Q&A session. I would just ask all of you who would like to raise questions to use the Q&A feature, which you should see in front of you, to raise any questions, and we'll do our very best to address all the questions that you may have. And once we've finished the Q&A session, we'll have a brief wrap up from each of the speakers and some concluding comments from myself. And we plan to finish by 1 o'clock UK time today. So I think that's all of the housekeeping out of the way. So I'd be delighted to introduce Professor Mercedes Maroto-Valer to join us. As I mentioned before, she is the champion and director of IDRIC, the UK Industrial Decarbonisation Research and Innovation Centre. Mercedes has been deeply involved in the acceleration of work around industrial clusters. She's got a very rich and broad experience working across a huge range of academia and sustainability areas as part of the Director of Research Centre for Carbon Solutions at Heriot-Watt University. She's got a broad range of research and innovation projects in energy systems, CCUS, integration of hydrogen technologies and low carbon fuels. And she has published over 550 publications, receiving numerous international prizes and awards. She's also a fellow of the IChemE, the RSA, and a number of other professional bodies, including the Energy Institute. So if I could welcome Mercedes to join us, look forward to hearing what you have to say.
Thanks very much, Nick. I hope you can hear me well. And I think I'm going to then start by sharing my screen. So let's see if this, okay, so okay, so I believe I'm sharing my screen, Nick. Please, can you let me know if you can see everything in the presenter's mode and it looks fine? Okay, I can't hear anything.
Mercedes, we're not seeing your screen yet.
You're not seeing my screen yet, okay? Can you see it now?
Indeed, all good.
Okay, perfect, thank you. So I'm just gonna keep going. If at any point it's something you don't see, let me know. I hope I'm not speaking to myself for the next 10 minutes. Well, first of all, thanks very much for the invitation. Delighted to be here and sharing plans and some of the things we are already doing and we've been doing for quite some time as well within the industrial clusters decarbonisation. So as Nick said, what I'm going to attempt to do in the next 10 minutes is just to give you a little bit of an overview of the industrial decarbonisation program. There will be more specifics as well discussed and presented later on, but also a little bit about the role of IDRIC within the landscape. Okay, so moving in terms of my first slide, I hope you can see it here. Okay. Sorry, just went back. There it goes. Okay, so if you look in terms of the screen that I have in there now, that shows what the UK targets are. I don't know whether there is the top screen, there is a banner on the top. I don't know if you see that as well.
It's just coming through, Mercedes. I think we've got some bandwidth issues, but I can see most of it coming through.
Okay,
so
perfect.
Carry on, and hopefully the technology will catch up with you.
I will. So what you can see in there is we have on the left-hand side is the net zero, looking in terms of what the CCC published in May 2019. A key message coming from the top graph is that we know we can decouple economic growth from CO2 emissions is evidence in that graph, although we also need to be clear that that has been achieved mainly because we have decarbonized the power sector. So what we have ahead of us to decarbonize and reach net zero, and that's the bottom graph that you have in there, is actually looking at transport, industry, and really the sectors that are quite difficult to decarbonize. So we need to make sure that we do more than what we have been doing up to now. And if you look in the right-hand side, that unpacks a little bit what that means for the manufacturing and the construction sector, looking at the 6 carbon budget, and in order to get us from the order of those 70 megatons that we are producing now from this sector in the UK to get us to the net zero. A point to make on that graph on the right, as you can see, lots of colors there. So what that means is that we are going to need a range of portfolios and technologies, and ultimately it's going to be how we integrate these technologies to provide solutions. And very key as well is how we have policies that actually are going to allow us to are going to incentivize and the business models to actually do the wider deployment that is needed. So if we look in terms of the challenges for decarbonization, as you can see there, again, a very colorful map, so give us an indication of a range of technologies. The challenges, as many of you know, is not because of the fuel that these sectors may use, but also there are emissions from the process itself. These processes are highly integrated, most of them operating at high temperatures. And also we need to consider that the plant lifetimes are going to be still for quite a period with us. And ultimately, and really key here, is that a lot of these products, they are low cost commodity products, and pretty much every single one of these sectors and industries, they operate on a global market. So we need to make sure that we actually keep them making competitive, and I would say actually more than that these sectors and these industries and these clusters attract inward investment. And this is also quite important as well in terms of considering the levelling agenda and how all those sectors are distributed across all of the UK. So I'm moving to the next slide. Hopefully technology is catching up here. This is the industrial decarbonisation strategy. This was published in March this year. And as you can see, we go from the left-hand side on those 70 megatons of CO2 to get us to reach 2050 targets. There are key milestones as we go along the way. 2 carbon clusters, if you can see in the 2025, another 2 more carbon clusters in the 2030s. The amount of CO2 we'll be capturing, and the world's first net zero cluster in the 2040s. Now, if you look in terms of how all this activity is going to be kicked off, then we look on the left of that the time chart there, and you can see on the left-hand side what we have is the industrial clusters are receiving funding for engineering studies, and this is part of the industrial clusters mission. And within this as well, what we have is actually the funding that was announced this year for IDRIC, the Industrial Decarbonisation Research and Innovation Centre. And as it says there, the text taken from the strategy, this is about bringing world-class universities that we have in the UK and the research institutions that we have to make sure we underpin the innovation needed to move from these very first clusters to the full deployment and net zero by 2050. So the industrial clusters mission, this was approved by Treasury back in summer 2019, and it was divided into 2 phases. Phase 1, it was about the development and planning, and phase 2 was really the delivery of the different elements. There are 3 elements to the program, as you have there. There is an element that is around demonstrators, deployments, infrastructure, that's in the order of 170 millions. There is an element around cluster plans and roadmaps in the order of 8 millions, and a third element in there that is IDRIC, the element on research and innovation. All these 3 elements are now into the delivery phase, that phase 2. And I think what is important to consider here is that these 3 elements work together within the industrial clusters mission. I'm not going to repeat, you have on the bottom the blue banner, the ambition of these clusters: 4 low carbon by 2030, 1 net zero by 2040, top up of 1 billion for CCUS, and we also have to consider a 240 million for net zero hydrogen fund. So these are all different elements that come together to make sure we have the key steps for the clusters to decarbonize and by extent decarbonisation of the industrial sector in the UK. So what is the role of IDRIC here? How is IDRIC looking in terms of delivering these solutions? So these solutions are here to actually help to accelerate the decarbonisation of the clusters. And there are 3 elements, or 3 wheels, if you see in that graph that you have. What we have on the top right-hand side is collaborations at the scale and pace, and this is really going to be critical for what we need to do. On the left-hand side, you have solutions, and I think here what is key to remember is that, yes, we need technologies, but equally we need policy, the business models, and the regulatory framework to come all together, and that's what we call solutions. And we need to make sure also that these solutions operate at the cluster level. I don't have time to go into that detail today, but quite a lot of the prior work has been focused more on process or particular facility. Quite a lot of the focus has been more on power generation, or at the other side of the spectrum, we've been looking at the national level. So what we're doing here is making it at a scale that is cluster and region, and is appropriate for that. And a key element that we should not forget is around a skills fit for the future. Nothing of this is going to happen if we don't have the workforce to transition to this net zero and help us in that transition. So what do I mean by collaborations of scale and pace? Within IDRIC, we have brought together 142 partners. You have there a breakdown from research organization, industry partners, associations, NGOs, and also policymakers and government bodies. These 142 partners have brought together 10 million in match funding in addition to the 20 million that is coming as funding from UKI. And I have mentioned technologies, have mentioned them in the context of solutions, policy, business models. And really what we need to understand here as well is, and the 2020s is a decade that is critical for action. A lot of what will happen later on, it will be dictated by what we do on the 2020s, or by default, what we don't do. And we need to be very careful with that as well. But if we look in terms of technologies, we'll be considering things around efficiency, whether it's resources or energy, CCUS. And in this diagram here, we'll have fuel switching. And within that fuel switching, what we have is hydrogen as a key vector and other vectors as well that we are considering within IDRIC. Again, the important thing to look in the diagram is really how busy is in the 2020 decade, how critical these times are. And then as we move 2030s and beyond, there is a little bit more of an uncertainty, if you want, around what technologies and the mix of those technologies that we will be deploying. But I want to highlight of this graph, oops, let me see, there it goes. What I want to highlight on this graph as well is that light bulb moment and that icon, and that is actually signaling for us innovation that will be key as we move forward. And as you see there, that light bulb happens at various times throughout this journey, and we will need to make sure that we have really the right environment and the right ecosystem of research and innovation, bringing it all together. And that's what we do in IDRIC in terms of ensuring not only giving support to the existing 2020s and the plans, but also going forward to meet our targets. I won't go into detail on this, but really what I want to highlight is, if you look on the left-hand side in terms of how we provided this foundation that is needed for technology and policy development, what you can see on the left-hand side is that we have industry-led research. Everything that we do in IDRIC is addressing an industrial challenge. If you move then through all those different circles, what you say is impacts to realize that research, making sure we have cross-learning, policy regulation, skills, and then getting into an international impact as well, that inward investment I mentioned before. And all this we are mapping around impact areas, around reducing costs, risks, timelines, emissions, economic aspects, and policy aspects. And this is really what is key for us as well. Every single one of our activities will be mapped against one of those impact areas, and we'll also make sure that it's related or connected or the potential to have an impact within a given industrial cluster. Moving really into my last slides now, Nick, looking at the time as well, is key this acceleration. If we don't do more than what we do now, it's just not going to happen. So we need to provide a catalyst. We need to accelerate this transition. So I already mentioned the role of IDRIC on the left-hand side around identifying, directing, coordinating research, this industrial alignment. And also when we look then at the right-hand side in terms of really that commercialization and those technologies and deployment and infrastructure, what IDRIC is doing or will do in that space is making sure that we share evidence, we stimulate the cross-learning within the clusters across the clusters as well, and we help to address wider issues like, for instance, policy and business model. It is going to be key that there is an element here of technology diffusion, and that technology diffusion can happen within across clusters and outside to disperse sites as well. Collaboration is key, and what we have been doing over the last year and will be doing more of that is actually going to the sectors that are represented within the clusters, going all the way from the chemical sector, steel sector, engineering sector, cement as well, and then making sure that we get them on board in terms of understanding what the challenges are and the opportunities by collaboration and the result of that in terms of accelerating decarbonization of clusters. So my last slide in terms of what's next, we are just about to launch the first tranche of our research and innovation projects. We'll be publishing a full list soon in our website. And also just to mention here, there are opportunities to engage in these first tranche of projects. So if you are interested and we haven't contacted you or haven't heard from us, please do get in touch. I'll give my details in the last slide. once we complete this launching of this first tranche, we are quickly and swiftly moving into an analysis of the industrial decarbonisation portfolio, looking in terms of doing a gap analysis. And this will really set the basis for a flexible funding and secondments that we have associated with that. And also will be scoping and putting in place the second tranche of research and innovation projects. And as I said, these are contact details. Please visit our website and you will be able to register there as well to get more details. You have our contact email, and just love to hear from you and just work together in really realizing this activity that is critical for the industrial clusters, but is really also critical for the UK to decarbonize. So I'm going to stop here, Nick. I'm just going to stop sharing as well, and I think I'm just within the time.
Perfect. Yeah, fantastic. And thank
sharing.
you so much, Mercedes, for that really, really helpful overview of the very broad set of activities that IDRIC is leading in this space. Just as a reminder, if you have got any questions, we'll be opening up for a sort of Q&A session after we've heard from each of the speakers. So please use the Q&A feature to ask any questions. So with that, thank you, Mercedes. And I would now like to introduce our next speaker, Julia Pike. Julia, as I mentioned before, is the Director of Financing and Economic Regulation at Sizewell C, part of EDF Energy. And Julia is working on a really interesting project to sort of try and figure out innovative ways of funding the Sizewell C project with government, looking at how value to consumers and potential investors and lenders are all brought together to effectively finance that project and potentially create a template for future projects. Julia's got a long and deep experience in working in regulation around power markets. Prior to working on this project, Julia was head of power and renewables for the UK, US and Europe at Herbert Smith and Freehills LLP, and led a cross-practice team focused on nuclear, wind, biomass and tidal projects. And Julia is also a fellow of the Energy Institute. So with that, Julia, over to you.
Thanks very much, Nick. So could we possibly go on to my next slide? I'll just say a bit about Sizewell C. What is it and why are we talking about it in the context of low carbon industrial clusters? So Sizewell C is a proposed new nuclear power station that will be built on the Suffolk coast. It's going to be a replication of Hinkley Point C, which will bring down the construction risk and will also give us the brain space to think about more creative uses of the electricity and also of heat, which I'll come on to. So where we are with Sizewell is that we have the detailed buildable design, which we're going to copy from Hinkley. We are in discussion with government on the proposed financing, as Nick's mentioned. We are in the middle of the planning process, so we're in the examination phase, and we hope to get a development consent order in the middle of next year. And we've applied for our nuclear site licence and environmental consents. And once the project is up and running, it will save 9 million tonnes of carbon a year. We've had a very detailed environmental product declaration analysis done for Sizewell by Ricardo, an environmental consultancy, and verified by WSP, to look at our life cycle carbon emissions, so taking account of the whole life cycle from construction, including fuel, uranium mining, fuel fabrication, all the way through to decommissioning. And whereas the IPCC gives nuclear a score of 12 grams of CO2 per megawatt, per kilowatt, the environmental product declaration is around about half of that, which makes it one of the very lowest carbon ways of making electricity that there is. So if we go on to the next slide, and I talk about why am I talking about a nuclear power station in the context of industrial clusters, and why has this not been part of people's thinking about industrial clusters? And that's been really because the nuclear power stations in the UK were built in the 50s, and then another generation in the late 60s and 70s. Those are the AGRs. which are now, as you have seen from the news, reaching the ends of their lives. And then the only new power stations built since then were Sizewell B, which went live in 1995, and Hinkley. And it's in copying the design of Hinkley that we now have the brain space to start thinking about what more can we do with a nuclear power station in the context of net zero. And the basic things that we can do are, we obviously produce a huge quantity of low carbon electricity, and we need to think about using that electricity obviously for the grid, but also for other uses. So for example, green hydrogen, and for example, cooling data centers, and for example, looking at desalination where the power station is in particularly dry regions, as for example, Suffolk is. But we're also looking at extracting heat. So that's something which is done from nuclear power stations elsewhere in the world and has been for a long time, and it's used for district heating schemes. The heat can be pumped in other countries up to around 80 kilometres. In the UK, this hasn't been done from nuclear before, but with Sizewell, we're going to extract clean, low carbon heat before it goes to make electricity. So with Sizewell, without changing the safety case, we can extract about 400 megawatt thermal of clean, low carbon heat at around 276 degrees. And that's within the existing safety case. We can explore making the safety case to extract more heat without making any physical change to the plant. And if we were to be able to build a third UK EPR, we could look at optimizing the balance further between electricity and heat. So the first reason that we're looking at industrial clusters is because we can produce electricity. The second reason is because we can extract heat, which can be used. And the third reason is actually the influence that a big project can bring to help businesses coalesce and make plans together. So if we go on to the next slide. We are looking at making hydrogen in the first instance from Sizewell B, and we're going to make that hydrogen for our own use to power hydrogen-powered buses, and as more and more hydrogen-powered construction plant becomes available, that construction plant, so not only lowering the carbon of construction, but also obviously reducing particulate emissions. But because we're doing that, we are talking to other people in the area around working together so that we can start marrying up greater hydrogen production to the increasing demand profile. So we're talking to local businesses, we're talking to the local councils, and I'll come on to an example about how we're working as part of Freeport East and looking at how to work with the ports to enable the ports to use hydrogen-powered port vehicles, but also starting to look at clean maritime fuel. And I think the power of a big project which is going to come into an area with a lot of infrastructure being built, when we are looking at installing our own refueling infrastructure, we can work with other people to install refueling infrastructure for more of Suffolk. And we can exercise the power of collective purchasing. And often the difficulty with hydrogen projects historically has been marrying up supply and demand. But because we're going to start off by making hydrogen for our own use, and we'll need sort of between 150 and 200 buses, so our own use is reasonably substantial. But it enables us to actually develop the supply to meet the demand, which is one of the most difficult things to do. And as the slide says, Suffolk isn't often necessarily thought of somewhere where you can actually create clusters, because it's not heavily industrialized, and nor is it seeking to be heavily industrialized. But we need to start looking at, as well as industrial clusters, at domestic clusters. So introducing hydrogen into people's daily lives. As I say, running clean buses through Ipswich, reducing particulate emissions, and showing people how the transition to net zero is actually going to really benefit their daily lives. The other thing about Suffolk is that it has tremendous renewables resources, in particular with offshore wind. So the electricity from a couple of offshore wind farms comes on shore very close to Sizewell C. And so we really need to be looking at how can we make technologies work together for consumers to have reduced bills and to make the best out of the qualities of the different technologies. So for hydrogen production, for example, to make the best use of the costs of electrolyzers, it's great if you've got the continuous power of nuclear and you're able to benefit from offshore wind, making best use of wind, electricity which the grid doesn't need on particularly windy days, for example. So I think working together across technologies is going to be key to the success of industrial clusters. And then the other reason, picking up on something that Mercedes said just now, is of course people, staff. We need to train people. Nuclear projects employ a lot of people. Sizewell C will create and or support around about 70,000 UK jobs, and joining together with other sectors to make sure that people are skilled in a cross-sector way so that we can make the most, both for the individuals of working in careers across green power, and also making the most efficient course administration, etc., for the further education colleges is another really important part of getting all of this to work as well as it can. So can we go on to my next slide, please? So Freeport East, which is based around Felixstowe, which is the UK's largest container port, and Harwich, is a great example of people working together. And you can just see from the slide the organisations which came together to make sure that when the Freeport is looked at, it's looked at in a way which involves clean industry, the provision of clean heat and power, and the production of green hydrogen for the Freeport. And it's a very nice graphic illustration of how working together you can make something which is much better than if we're taking a single sector approach to life. So if we can go on to my next slide, please, which is direct air capture. So we have a great opportunity to make the power station actually carbon negative. So direct air capture at the moment is a technology which is developing, and we are working with the University of Nottingham and with Strata and with Doosan Babcock to develop a technology which, rather than being powered by electricity, would be powered by heat. And remember, the heat from Sizewell C, if we extract 400 megawatt thermal, it has minimal impact on electrical output, so the heat is cheap. So using this heat rather than electricity can very significantly lower the cost of direct air capture. So we applied in consortium for funding from the BEIS competition for greenhouse gas removal technologies, and it's a really exciting opportunity to develop it. If we are able to develop a third UK EPR project, this is something which we would look to do at greater scale. And as I said, possibly optimize the balance between heat extraction and electricity even further. Even with taking out only 400 megawatt thermal, which doesn't, as I say, have a significant impact on electrical output, using this direct air capture technology, it would offset or capture the carbon which is put out by the UK's rail industry today. So that is a fantastic opportunity for us. So if we go on to the next slide, which is my final slide, if we remember why are we doing all of this? We're doing all of this because we have to achieve net zero, because we have to mitigate climate change, and if possible, look for our technologies to become carbon negative, remembering the net in net zero. And so, as well as looking at technological solutions and seeking to build a power station to produce huge amounts of low carbon electricity and heat, we are working with the town council in Leiston, which is the town which is nearest to Sizewell. And what we're doing is running something which is a bit like Dragon's Den. We have with our partners who are shown there, Atkins, Oppergy, Carbon 4, the Energy Systems Catapult, Ikigai Capital, the Council for East Suffolk and Suffolk County Council, we have produced an engineering route map which analyses the carbon emissions from Leiston and produces an engineered route map to say what is it you can do to actually reduce these emissions to zero. But because this is primarily about people, as I say, it operates like Dragon's Den, in which the town council operate as the dragons. We put forward solutions which are to do with insulation, cladding, replacement of heat sources, installation of wind turbine solar panels, installation of EV charging points. We're looking at hydrogen opportunities, etc. And what it's going to teach us is what is socially acceptable. We're looking to do this as an open source route map for other towns where, like Leiston, they are quite rural, isolated, very heavy dependence on cars because there's not a huge amount of public transport. People drive to work, people have to drive to get to further education in particular. And we are very much hoping that this can provide a really useful route map to what is a socially acceptable way of achieving net zero, which needs to sit alongside our industrial clusters, our domestic clusters, and all our individual sector technologies. So if I stop there, Nick.
Fantastic. Well, thank you so much, Julia. I'm intrigued and fascinated by the use of all of that excess heat, and I guess just as a slight aside, I'm sure many of you have been watching the programme on BBC Two on the construction of Hinkley Point C, and just the scale of cooling required, and conversely to think about other uses for that heat is clearly a really exciting opportunity that you've outlaid, both for hydrogen, direct air capture, and no doubt other uses. So many thanks for that, Julia. So our final speaker, I'm delighted to introduce, is Dan Sadler. Dan is the UK Low Carbon Strategy Director at Equinor. Dan is a chartered engineer with over 20 years industrial experience. He's really spent a lot of his time working around natural gas as a project manager for high pressure pipelines and pressure reduction stations. And prior to joining Equinor in 2019, Dan worked as the divisional director for Riyadh Group. Dan's been involved in a number of the low carbon projects. I think it's the H21 project in Leeds that Dan's previously worked on, as well as other industrial gas clusters. So with that, Dan, I'm looking forward to hearing more about your perspectives from Equinor. Over to you.
Yeah, thanks, Nick, and morning or afternoon, everybody. I'll just share my screen. So hopefully you can see that, yeah.
Yes, we can. Thanks, Dan.
Okay, so I'm going to talk specifically about the Humber for a short period today. Just before I do, it's just worth probably mentioning that for those who don't know Equinor, we're a broad energy company, obviously traditional oil and gas company, but we now have an expanding renewables portfolio. With we're just building Dogger Bank, for example, just off the northeast coast with our partners SSE and Eni, which is the world's biggest wind farm, and we also built the world's first floating wind farm off Scotland, as well as building the wind farms off New York as well. So growing portfolio in the renewable space. But I also think in terms of the hydrogen economy, which isn't just the focus of this today, but we're probably quite uniquely placed to talk about blue and green. Obviously, we've got the big renewables division in terms of the wind, but in terms of the blue hydrogen element, we also are the only commercial CCS operator in Europe, operating Schnurr and Spikener since 98 and 2008, and also just building Northern Lights, the world's first CO2 shipping import terminal, as well as we manage and operate the Chelvergod methanol plant with both SMR and ATR technology at 700 megawatts. So probably well placed to have a pretty broad view on different energy pathways. So just coming back onto Humber for a second, well, for the remainder of the session really, I'll just talk about the zero carbon Humber industrial cluster. For those who don't know, the Humber's the biggest industrial cluster in the UK by a considerable margin. Actually, it's a huge industrial area with about 12.4 million tonnes of industrial emissions and around 20 odd million tonnes when you actually start counting power generation. And I'll walk you through the Humber in a minute. But the Zero Carbon Humber Partnership was a project that was successfully progressed through the Industrial Strategy Challenge Fund as part of the Industrial Decarbonisation Challenge that Mercedes mentioned earlier. So this is a formally backed project now with both private and public sector funding. And the partners you can see on the screen there make up that consortium with the likes of Equinor, National Grid, IDRIC, Centrica, SSE, British Steel, AB Ports, PX, Triton, Uniper, Mitsubishi, and the AMRC will come and talk about in a minute. So it is a real coming together of some pretty big national and multinational players to decarbonise what really should be an international lighthouse of decarbonisation technologies to the UK. So just to walk you through the Humber for those who are maybe not too familiar. Coming in from the east coast is the Easington, where a significant amount of the UK's gas lands. Coming further inland still, we've got the Saltend Chemicals Park, which is one of the oldest chemical parks in the UK, producing around 2 million essential chemical products for export across the globe, 2 million tonnes every year. And that's about, I think it's 107 years old this year. Coming across the estuary, you've got the Immingham area, which is home to Uniper's Killingholme power station, as well as a third of the UK's refinery capacity. Further inland still, and you've got British Steel, one of only two primary remaining steelworks in the UK using blast furnace technology. A little bit further past Scunthorpe, you've got Keighley, which is SSE's site, where there's ambitions for both post-combustion capture and 100% hydrogen power generation. And then at the end of the Humber is, I suppose, the jewel in the crown, which is the Drax power station, which is Europe's biggest biomass power station, and by biggest, it's biggest by a significant margin, with 16 million tonnes of bio-CO2 available for BECCS or biofuel generation. So what the Zero Carbon Humber project is actually about developing critical infrastructure, linking all these major emission points across the region, allow them to decarbonise with a combination of both hydrogen fuel switching and post-combustion capture. Now, the thing that all industrial regions need to get to net zero is they need CCS for those industries that can't fuel switch or convert to electric. They need hydrogen distribution for those industries that can fuel switch, and they need an element of negative emissions or bioenergy carbon capture and storage to offset those difficult to decarbonise sectors. And that's what this project is about doing, linking all those regions so that they can choose the complementary technology that best suits the process or the industry or the application, and transition this hugely important industrial cluster to net zero during the 2030s actually. So that's the onshore infrastructure, and I'll just talk about these projects in a little bit because there's multiple projects developing along that infrastructure. But any onshore infrastructure obviously needs to connect to an offshore system in terms of the CO2 TNS. So also successful through the Industrial Decarbonisation Challenge was the Northern Endurance Partnership project, which is effectively the offshore element to that onshore infrastructure. It's quite a unique proposition on the basis that it is a kind of 2-for-1 offer, I suppose, to government, where you've got one store or one storage system facilitating decarbonisation of two critical industrial regions, those being Humber and Teesside. Teesside also has the Net Zero Teesside project, which was in the Industrial Decarbonisation Challenge, but I won't touch on that today on the interest of time. Importantly, actually, this scheme on its own could meet the Committee on Climate Change recommendations to have 10 million tonnes of carbon stored by 2030, and also its recommendations that at least one of those for substantial production of low carbon hydrogen, and that one in the first instance the Humber. Now, again, you can see the partnership who are delivering this scheme. So some of the world's leading companies bringing all that expertise and knowledge to bear to ensure that we can actually deliver this project, and not only deliver this project to decarbonise around 50% of industrial emissions in the UK, but also to really produce that international lighthouse of technologies and share that knowledge across other industrial regions, both in the UK and across the world, to help that decarbonisation transition globally. Excuse me. So just onto the projects, so I'll skip the slide there. So Salt End, if you remember from that map I showed initially, is the initial anchor project for the Humber infrastructure under the Industrial Decarbonisation Challenge. The Salt End Chemicals Park, to put it into perspective of how big this park is, it emits 3.5 million tonnes of carbon every year. If you just put that into context with the UK industrial clusters, that's more carbon emissions than all of Moorside or all of Teesside put together. So it's a huge industrial region in its own right, and it's one of the emitter regions within the Humber. Now, this is a picture on an extremely nice day. You don't get too many of them, and I've been here a lot. But what you can see there is you can see the chemicals park. Up in this top corner is the Triton CHP power station, providing power and steam for the chemicals production. And then on the side, there's companies like INEOS producing acetic acid, Yara with ammonia, Virgo producing a bioethanol, and Humberside producing critical chemicals for the globe. The plan is to build a 600 megawatt thermal reformer in the first instance, so this is here. The fuel switch, the Triton CHP, which uses Mitsubishi turbines, as well as producing a large low carbon ammonia product for export into the international green products market, and also to support decarbonisation of maritime. We also have the option to blend into the gas networks if that's appropriate at this point, and fuel switching other large industrial users on the site. So really a very integrated low carbon fuel switch solution, and that would reduce emissions in the chemical part by around 1 million tonnes per annum by 2026. And from there, what we do is we add more blue hydrogen capacity, but we also actually add green hydrogen capacity. So I mentioned Dogger Bank earlier, which is the world's biggest wind farm. That will land in both Teesside and Humber, landing on the North Bank. And the aim is to also integrate with the Dogger Bank renewable electric to produce green hydrogen product for input into this low carbon network. And indeed, that hydrogen transmission system going across the Humber. Just on to some of the other projects that are being unlocked as part of this infrastructure. And by the way, National Grid Ventures are the lead on the infrastructure development, with us co-developing Equinor. You've got the Uniper Hydrogen Hub, so if you think just in that Immingham area, Uniper has ambitions to develop a hydrogen hub there, again with blue and green hydrogen, making use of that hydrogen transmission system so that we can link supply and demand in terms of hydrogen demand with credible supply locations. There's 32 hectares of land available there, so they've got very clear strategies in terms of supply and demand and very clear ambitions in that region. Going across to British Steel, again, if you come just further inland, British Steel have got a complementary strategy for both carbon capture and storage, as well as hydrogen fuel switching. You can imagine steelworks are heavily integrated works where you've got the blast furnace technology, which is a chemical process, as well as use of the off gases in power generation, etc., across the steelworks. So they can use a range of technologies based on both CCS and hydrogen fuel switch. By the way, Equinor are working with ThyssenKrupp in Germany to decarbonise their Europe's biggest steelworks with 100% hydrogen fuel switch before 2050. Coming inland still, we've got the Keadby Clean Power Hub, which is a combined project with SSE and Equinor. The Keadby Clean Power Hub is based just to the west of Scunthorpe. Equinor also own with SSE Alba, which is some of the biggest onshore storage in the UK. And what we're looking at doing at the Keadby Clean Power Hub is producing a post-combustion power CCGT for flexible power generation, where we capture the carbon after on emission, but also producing a 100% hydrogen power station for the world's first 100% hydrogen CCGT, which can work perfectly with flexible power, working alongside intermittent renewables to get that 100% decarbonisation towards 2050. Keadby 2, which is being built at the moment, I think it's due to commission next year, will be Europe's most efficient CCGT when it's commissioned. And we're also looking to blend large or significant hydrogen content into that decarbonising Keadby 2. And then on to DRAX. DRAX was at the end of the pipeline system as is in terms of the industrial cluster. Huge opportunity for negative emissions. I think DRAX can provide a third of the negative emissions recommended by the Committee on Climate Change just from that single site, with the first conversion of one of its units to provide 4 million tonnes, increasing to 8 million tonnes potentially by 2029. Huge. So I think the kind of message here is it's a very well joined up strategy, a very strong collaboration centred around credible projects with international backers who can actually deliver these mega scale projects with a real transition to net zero over the coming decade. The last couple of slides from me, as well as this kind of hotbed of decarbonisation technologies in the Humber, the other thing that we're doing as part of the project is working with the AMRC, which is the Advanced Manufacturing Research Centre, to develop a new Fit for Net Zero programme. And that is really dovetailing off the back of the successful Fit for Nuclear programme developed between 2014 and 2020. And the aim of this programme is to actually look at these new nascent markets, both CCS and hydrogen, and really be able to kind of map that to UK supply chain capability, and then identify gaps, work with those manufacturers to see if we can improve their manufacture process, or indeed educate them on how to develop their manufacturing process so that the UK supply chain can take a maximum advantage of these new markets as they develop. If you look at the Fit for Nuclear programme, as much as obviously nuclear maybe hasn't taken off as much as we thought, already from that programme they've generated £1.9 billion worth of new contract wins from the work, not necessarily all in nuclear, I hasten to add, and created over 8,000 new jobs. So we're looking to replicate that in these new low carbon markets in these industrial clusters. I'll kind of skip over this slide a little bit, but you can see how well this maps to the UK government's 10-point plan. There's 8 of the points there from the Humber. Hydrogen economy, CCS, obviously I've touched on. The finance and the jet zero and green ships I've touched on, with biofuels and also ammonia for maritime. Offshore wind, Humber's known as the UK's energy estuary, with I think more wind due to land there than anywhere else, with the Hornsey wind farms on the south bank and the Dogger Bank on the north. We can decarbonise heat akin to the H21 projects, and obviously coming alongside that is decarbonisation of transport with both hydrogen and electric. The last thing that I'd leave you with, there's quite an important process going on at the minute, which probably everybody should be aware of, which is the UK government cluster sequencing process. And what they're trying to do is set a natural sequencing for how industrial clusters should be engaged with government in terms of business models to unlock these projects, produce a commercial framework against which to take a final investment. And this is actually going on at the moment. So all the industrial clusters in the UK are competing or pseudo-competing into this competition or this process. The cluster plans, which are really centred around the infrastructure in the first instance, are due in. This is slide actually, they're due in on the 9th of July. We will know which clusters are track 1. Those will be the first to deploy low carbon infrastructure in the UK in the mid-20s, sometime in August. That's probably from August the 25th. And then the primary emitters, so projects that wish to connect, all of the ones I've just mentioned being applicable, can then submit to a phase 2 process where government will also look at which projects it wants to initially negotiate with as the first project to connect to these systems. So that is a live process going on at the moment. So I've specifically focused on the industrial decarbonisation challenge, that things will evolve as that process matures. critically in 2021. And that wraps up. Hopefully I'm about on time there, Nick, and with that I'll pass back to you.
Perfect. Well, we're perfectly on time, so thank you very much for that, Dan. So we're going to invite the other speakers to come back on screen now. So Julia and Mercedes, if you could kindly rejoin us. Just as a reminder, if you have got questions, please do enter them into the Q&A box, which you're hopefully accessing. Okay. Dan, your microphone is a little bit in and out. We did hear you, but at times it was a bit difficult. So if I could just ask you to have a little play with your microphone, see if you can get that bit better for the Q&A session, that would be great. And whilst you're doing that, I'm going to take the first question, and this is to you, Mercedes. It's a question from Nicola Lowry, who's asking whether the industrial clusters mission that you mentioned is funded by IDRIC or whether that's something difficult. And then I've got a question, Mercedes, which I'll come to after you've addressed that first one.
Yeah, thanks, Nick. So this is all part of the industrial decarbonisation challenge. So that's where the funding for IDRIC comes, and within that we call this also within the industrial clusters mission. But we are talking about the same initial pot of funding that was originally announced in 2019, and then 2020 was the process of the phase one that we call, where it was the plans put in place. It was a bit of a competition as well in there, and then resulted on 2021 and phase two for the deployment, IDRIC, and the cluster plans. And the presentation and some of the projects that Dan was mentioning, they also refer as part of this package of funding as well.
Great, thank you for confirming that, and thanks for the question, Nicola. And sort of, I mean, just going into the clusters, I mean, there's a lot of focus on these clusters, which are a big part of the emissions mix, but around 50% of our industry in the UK is not clustered, it's dispersed. Is it right that we put all the focus on these clusters rather than the entirety of our emissions?
That's a very good question, Nick, and one I kept getting asked many times, so hopefully I master the answer as I do this over times. I think it's really what we need to consider here is not either or. We need to decarbonize everything to start with. So we need to decarbonize the industrial clusters, and we need to decarbonize the dispersed sites. So I think we need to start with it's not an either or. However, what we also need to be clear is that by starting with these clusters, what this gives us are the opportunities of early deployment, the opportunities of economies of scale, the opportunities of taking advantage of the existing infrastructure, and also there is a number of projects, as Dan highlighted in his presentation for the Humber, and activities that are already happening. So I think what the clusters give us is the unique opportunity to get the process going or making it happen faster, because there's a lot going on. And then what we need to make sure is that we actually have a process where we actually can talk about portability of solutions. So how do we get these solutions that are in the clusters applicable to dispersed sites? And I think that part of the answer to that, it comes taking into consideration that the clusters are very different, each of them in their own right, because of the size, as Dan already mentioned, the type of emissions, the industrial sectors that they are represented in some cases. So we're going to have a portfolio of solutions coming from the clusters, and then we need to make sure we make them portable to dispersed sites. And the question then becomes about how portable these solutions are, right? And I think there are two angles that we need to consider here. One of them related to portability is going to be depending on the infrastructure that we build and the networks that we build, not just within the clusters, but across. And here I'm talking about networks about CO2 or hydrogen transport, a wide range of things we need to consider. And then I think in terms of the portability, the other angle as well that is going to help us is innovation, and how we're going to be able to get these solutions and these lessons that we learn and these business models and actually be able to roll them out to other parts.
Thank you, Mercedes. And we'll come back to innovation in a minute. Before we go there, we heard a little bit about the supply chain. Dan, you were just mentioning that. So maybe I could go to Julia first and ask Julia, what proportion of the UK, of the supply chain is coming from the UK, and how are you thinking about that? And perhaps, Dan, we can sort of go to you after Julia's commented, and Mercedes too, if you want to come in on that. So Julia, what proportion of the supply chain is coming from the UK?
So for Sizewell C, it will be around about 70%, possibly a bit more in construction, and then in operation, it's going to be close to 100% or 100%. I think what's really interesting for us to look at the moment is how we can join up to develop things like direct air capture and green hydrogen, and make sure that those two come from a predominantly UK supply chain if we can. I mean, it's great that our direct air capture technology is being developed with Nottingham University, Strata and Doosan in the UK.
Thank you, and that's encouraging numbers you've given there. So, I mean, Dan, from your perspective, I mean, you talk quite broadly. I know there's a lot of focus on the sort of UK supply chain coming into areas like offshore wind, where historically a lot of the manufacturing has taken place elsewhere in the world. Can you elaborate more on how you're thinking about supply chain?
Yeah, I mean, I'm actually the chair of the Hydrogen Advisory Council Sector Development Working Group for Government, which is specifically looking at this task. And what we need to, first of all, we need to recognise that UK manufacture is difficult to compete with, you know, the likes of Poland or China, where obviously the labour costs are so much cheaper. So that's why with that AMRC programme, we're looking at advanced manufacturing. How do we be more efficient? How do we advance our manufacturing? But the challenge with these new markets is they are quite literally new markets. You know, if you look at the hydrogen economy, you've not only got production, but you've got compression associated with that. You've got end use and a diverse portfolio of end use, from CCGTs, where you could say, well, actually, it's unlikely Mitsubishi are going to build their turbines in the UK or Siemens, but actually you've got buses and transport and engines and you know, maritime, and you know, so when you start looking at the applications of the onset of the hydrogen economy, I think the challenge is, where do we really want to play? Because it's not just about UK projects, it's about export, because the world is also looking at being able to develop hydrogen economies. It's consistent across Europe, it's consistent in places like Australia, Japan, Canada. So actually we need to find that balance. You know, we don't need to boil the ocean. We want to get the low hanging fruit, then get the next step, then get the next step. But you're absolutely right. What we want to try to avoid, if at all possible, is just being involved in the final assembly. So there's people like ITM Power, who produce, that's the world's biggest electrolyser factory, producing PEM electrolyzers in Sheffield. What a fantastic success story for UK, low regrets, because we want green hydrogen. Globally, there's a big export market. Do we want to focus on buses? Do we want to focus on compression with the synergies with CCS? So, you know, we're really trying to get under the skin of where's the best place to start to ensure that we can, you know, get the best bang for our buck, but recognising that the UK government, in terms of its business models, also needs to, one, not prevent projects progressing by putting artificial onerous targets on it, but also that we recognise there may be a cost for an enhanced UK supply chain, but how do you then assess the value?
Thanks, Dan. And Mercedes, anything you'd like to add from your perspective?
I think it has been quite well covered already. It just maybe to reinforce the point of we need to bring the supply chain with us, and I think that's going to be quite important, because that will give us a lot of opportunities for export as well. So I think we need to be looking at decarbonisation as an opportunity to grow our business, not just keep them. This is not just about adapting to survive. This is really innovation to thrive. And I think that's what we need to consider, how we bring together that supply chain. So we actually have export. It's just not bringing things from other places and just do the assembly here.
Thank you. So we've talked a lot about innovation, and you know, I guess a lot of these technologies are going to be deployed within the next decade, through the 2020s. And so maybe, Mercedes, I'll ask you to sort of lead this, but it'd be great if Dan and Julia want to come in as well. How much of the technology we need to deploy over the next 10 years is ready and available to be deployed today versus what needs to be developed? So what are the gaps?
So I think we have technologies that are ready to be deployed. And I think that's clear when you look, for instance, at some of the projects that both Julia and Dan presented. So there are technologies that we have. the 2020s, I think the focus of the decade that we are now is actually making sure that those technologies and those solutions are deployed at the scale, are demonstrated, that we build the business models, policy, regulatory frameworks. But at the same time, there is more uncertainty going forward as well in terms of how we can reduce costs or reduce the risks of these technologies. And I think this is where innovation is going to be key. If you look at the report published by EIA, I think it was just only a couple of weeks ago, maybe even a bit more than that. But the road to net zero, what it was clear there, one of the very first messages in that report is that the transition is going to require innovation. So it's not going to happen unless we have innovation. We are going to be able to do significant steps, but it's not going to get us all the way to where we need to be. And then actually they went even farther than that, and they said the current level of investment that we have of $25 billion is not going to be enough. We need to actually make sure that we go up into the 90s if we really are going to have the innovation needed for that transition. There is a portfolio of projects that we have to make sure we demonstrate, but innovation is going to help us to have new industries, the supply chains that we said before, commercial opportunities, employment opportunities. And this is where, within the context of the industrial clusters, is where IDRIC comes into play, how we can actually make sure we support and we provide the research and innovation needed. So we go back and, as I said before, reduce costs, the timelines, the risks, economic policy aspects, and that's a key element to really get to net zero.
Thanks, Mercedes. Julia, Dan, you want to come in on that? Dan, you're on.
So I think, first of all, I think it's important to point out that to get started, all these technologies exist. What we're doing is piecing together a jigsaw of technologies that have been around for decades. Pipelines for hydrogen. I think the first one built was in 1938. The Rhine Row, still going. CCS, we've been doing it in Equinor for 25 years. We own Technology Centre Mongstad in Norway with Shell and Total, where it's the world's biggest CCS testing facility. Hydrogen production, we've been adding between 3.5 and 7.5 gigawatts of production on average every year for the last 50. So it's, these technologies exist, is the first point. So we can get going. It's the business models to get going that don't fully exist yet to put a commercial framework around this, but that's being developed. The thing that I would say is, with the hydrogen economy specifically, what we have to be able to do is start the economy at scale, justifying supply and demand, because scale justifies infrastructure. You don't fill the ocean with a tap. So you want, gigawatt scale production linking to gigawatt scale demand. And that's where in Equinor we look at things like ammonia, big industrial fuel switch at the technologies that are ready, with also power generation. So significant blending initially into gas turbines, but then 100% turbines. And what that does is then lowers the threshold for everyone else to develop their technologies. And a great example of this would be, for example, you can't justify infrastructure for HTVs because it's an organic growth activity. There'll be one, then there'll be two. Well, you're not going to spend 400 million on a pipeline to do that. So what you do is you lower the threshold, and that can organically grow. But I think once you get that hydrogen economy going, the innovation can just really take off. I think when I wrote the H21 report in 2016, there was 21 ways to produce hydrogen. But only 3 of those have ever really been deployed at scale. Most of them are university projects, because where's the demand? Where's the demand? Whereas all of a sudden, if you start to produce these low carbon hydrogen markets, there could be all sorts of different ways of deploying the technology, both on production and end use, that really can take off because there's a commercial driver for them.
Thanks, Dan. And I guess we've talked a lot about sort of the role of government in this. So, I mean, if I could maybe bring in Julia to speak about where are the gaps in sort of regulation, or the things that need to be clearer to be worked through? What does it need to be put in place that will help projects like Sizewell C actually move forward? Julia, your mic's not on yet.
I knew I'd do it once. So So picking up on what Dan was saying just now about this issue of marrying up supply and demand, I think if you look at something like Sizewell, where we have a core project, we have a design, we can build it, and therefore we have the brain space to think, well, now let's take off some heat, and now how can we use the heat? So now let's develop direct air capture, and now let's use hydrogen, and so we can actually scale supply to demand, which is as Dan was saying, it's the difficult thing. It's how we can't start off by saying let's have a wholly hydrogen fuel construction period, because we don't have the vehicles, but the vehicles won't develop unless we demand the vehicles, sort of the industry collectively. So I think that where there are opportunities with big at-scale projects like Sizewell, but there's plenty others, and this isn't a competitive conversation at all. We need everybody to succeed in order to achieve net zero across all sectors. But I think that things around government business cases, what is Sizewell C? Well, it's a power station. But if the government business case process could also look more widely at the fantastic opportunities it offers to enable the construction plant manufacturers to scale up and experiment with their conversion to hydrogen plant, to look at the opportunity to, for example, create a domestic cluster for hydrogen, and the opportunity to experiment with direct air capture. Things can be looked at in a slightly siloed way, so that on the one hand, we can be awarded funding from BEIS to develop direct air capture, which is extremely welcome. But on the other hand, how will it be valued in the overall business case for the power station? And making sure that those two things are married, I think that would be really helpful. And I think the other thing that's going to need to be looked at is making sure that all regulators are aligned on a net zero duty. So not all of the regulators have net zero duties. So for example, the DEFRA family of regulators, so that's the Environment Agency, the MMO, etc., they don't have a net zero duty. And I think that a really aligned net zero duty would smooth the path. That's not to suggest that extremely high standards of environmental protection need to be maintained. They do. But I think working towards an aligned set of understandings around prioritisation and net zero would really help us structure some of the infrastructure that we're going to need to get to net zero.
Sure. And thank you for those perspectives. Dan, from your vantage point, what further gaps or opportunities do you see around government policy and regulation? Dan, we can't hear you.
Yeah, sorry. I mean, government policy in the UK, I think, is quite progressive. When you look against mainland Europe, I think it's quite pragmatic. It recognises, for example, blue and green and the importance of that, the importance of you just need to get on with everything. I think the great thing is that when we settled the Climate Change Act, we also established the Committee on Climate Change as an agnostic organisation to kind of, if you like, hold government's feet to the fire on their legally binding targets. I think the fact that the sixth carbon budget has now been adopted in law, which means that by 2035 we need to reduce emissions by 78% at 1990 levels. That's about 60% further from today in 14 years. That is a huge challenge. But what a great challenge, and I think it's the most probably the most aggressive legally binding target in the world. So the kind of ambition is there. What we really need to unlock that ambition is firstly to get on with the projects. We need to really back these projects, and there's movements to do that. But a lot of these projects are pre-FID. Well, all of the projects are pre-FID, so pre-final investment decision. And to take a FID, we need to establish the commercial framework to make these projects commercially fly. And that means we need to establish business models. Business models aren't just about finance, they're about allocation of risk, etc. for nascent markets. So the government, I think, is doing a great job on the CO2 TNS systems. That's looking like a regulatory framework model. On the hydrogen transmission system, that's maybe not quite as clear yet. We recommended in our Hays 21 report that should likely be a regulatory framework model because it's socialised infrastructure. And then against a range of emitter projects, whether it's IDRIC or SSE or Uniper or Equinor or whoever, there needs to be a diversity of business models supporting the actual projects, not just the infrastructure. So that could be a contract for difference on power gen, which is a dispatchable power agreement we're looking at. or it's an industrial carbon capture agreement, or it's a hydrogen fuel switch agreement. So it's developing the business models that enable the actual projects to take a FID, and then like anything, you take a FID, then you can start to drive down the cost of economies of scale and really deploying on a large basis, and also and ensure that the UK gets that first mover advantage.
So thanks, Dan. So you've talked about government. If I could sort of expand it to around communities, and there's clearly a lot of you Dan and Julia both talk quite powerfully about the role of these clusters within the communities in which you operate. Could you say more? Maybe we'll start with Julia on how you are engaging with the public, particularly in new areas such as CCUS and hydrogen, where the public perhaps doesn't have the knowledge and it hasn't had the exposure to previously. How you engage with the public around those topics, and talk about the sort of balance between, I guess, the unknown and concerns versus the opportunity for jobs and prosperity within the communities that you're operating.
That's a really good question, and I think that it's a discussion which I had with some people at the Hydrogen APPG. Actually, is around how to make sure that the narrative on hydrogen remains positive throughout. And I think that the nuclear industry probably does have quite a few useful lessons around how to address with the public concerns about safety, which can appear misplaced to the industry, but are very real and very powerful, and actually will play into how the industry is actually able to develop. So I think it's really important to get the narrative right from the start. People do perceive there to be safety issues with hydrogen, and it's for the industry to get it right, to make sure that the right balance is expressed around maintaining public safety. And then with the community more generally, I think that helping people see the ways that the transition to net zero can really positively impact their lives. I think there are lots of issues around acceptance of infrastructure. There's on the one hand people like want renewable electricity, but people on the whole don't want large transmission lines running across their neighbourhoods, and that's an issue. People on the whole accept the need for more nuclear power, but people who live near nuclear power stations understandably aren't keen on construction disruption, and that's something which we have to handle. And I think helping people see how on the whole lives will get better, and I think that's a mixture of making sure that we can develop things like a domestic hydrogen cluster, as I say, helping people see that heavy goods vehicles and buses which emit water can really be a better thing in their daily lives, and also looking at the business models and making sure that people themselves feel that they can benefit, and that the whole green transition is not ending up owned exclusively by financial institutions and government, but that with the government we do develop opportunities for individuals to invest and feel that they've got a stake in it.
Thanks, Julia. And Dan, from your perspective?
Yeah, I mean, I think the first point to make is that public acceptance and support is critical, because that supports the ongoing political will for a start. But the public have to come on this journey with us, and I think the first thing we have to do is educate the public. These conversations should be around the dinner table. So whereas what we tend to get is people will talk about renewable energy because you can see it. I mean, my kids will know what a wind turbine is, and they know what a solar panel is, but do they know what CCS is and the hydrogen economy? Well, my kids do, because that's what I talk about, but most kids don't. So I think that we need to get the conversations around the dinner table. I think that we need to have a very diverse and inclusive approach in terms of community engagement, to make sure that we're not just presenting at conferences to people that have an interest in this topic, but actually we're imaginative about how we educate across the general public, so that they kind of feel that shared value in terms of not only the critical nature of these activities in terms of climate change, but also the economic prosperity that they can bring with them to their regions, not just in terms of economics, but also in terms of development of infrastructure in the region, which comes alongside economic prosperity, and also the potential health improvements to things like decarbonisation of transport. But I think the other thing that I do really support in terms of the industrial clusters decarbonisation, the H21 project was looking at fuel switching all the gas networks and converting houses to hydrogen. Now that's a pretty scary first step to a mass populace who probably aren't that aware of the difference between natural gas and hydrogen. So I think starting off with these industrial clusters, one is starting these new industries in areas that are more used to this type of technology. So it's more comfortable anyway. But then what it will do is it will start these type of new markets and this new infrastructure in areas that are familiar with it. And then alongside that, we can educate and grow public familiarity. Because decarbonising industrial clusters makes a tangible impact on climate change emissions, whilst establishing the infrastructure that can then expand beyond those industrial clusters into these wider energy market sectors. And I noticed there was a question in the chat about, why does the hydrogen pipeline extend to Drax? And that's because actually the aim is to have a hydrogen pipeline built in parallel with the CO2 that can reach Drax, where you may combine it with biofuels, but actually expand beyond the industrial cluster ultimately into the major urban centres to help decarbonise transport and heating and power.
Well, thanks for preempting my next question, Dan, and that's a helpful answer. So I guess you've mentioned there about hydrogen and hydrogen coming into the home to decarbonise heat. At the risk of sort of throwing quite a hot potato into the debate here, but I think a very live conversation. There's a lot of hype around hydrogen at the moment. Just looking at some of the valuations of some of the companies involved with hydrogen, that really sort of makes that point very clear. And there's also some quite polarized debate. And as many of you know, the Energy Institute, it really prides itself on its sort of fact-based, unbiased point of view, but convening the debate. And one of the debates that I'm personally very keen to pull together is around how we decarbonise heat domestically here in the UK. And there are those who argue very strongly and compellingly about the role of electrify everything and heat pumps. There are those that argue the case for district heating, and there are those that argue the case for hydrogen. Perhaps we could maybe go back to Julia and sort of maybe hear your perspectives, maybe coming a bit more from the electrification side, although you've mentioned hydrogen too. And then back to Dan and sort of maybe, creating the case for hydrogen in domestic heating. So, Julia, if you're happy to tackle that, what's the case for electrifying everything in UK domestic heating?
Well, disappointingly, I don't think there is a case for electrifying everything in domestic heating. I absolutely think that we're going to end up with a mix of hydrogen and electricity, both in vehicles and in heating, and I think it will be place-based. I think there will be places where it works well to look at putting more hydrogen into the gas grid, and I think there'll be other places. I mean, obviously places where there isn't a gas grid, and then there'll be other places where it's not really practicable and where heat pumps do take off. But I just think that as across almost everything with this net zero debate, we really need everybody to succeed and work together, and we need to as an industry sort of, and I think it is, and I think cooperation is increasing in competition between sort of, is this good, is this better than this? I think that is declining. We really have to support everything happening, because there's a vast amount to do, and everybody really is going to end up with a place as we hopefully achieve net zero with public acceptance. I think the basic guide should be, does it work for people? Will people accept the experience? And does it keep electricity and heating bills at an acceptable level, bearing in mind that this will impact most harshly on the least well-off in society?
Dan?
Okay, I mean, this is a topic I could talk on for hours and hours. I've quite literally written the book on it. So if you look at the H21 North of England report, the challenge with heat is that it's interseasonal, as everybody knows, but it's also, homes in the UK are designed for central heating systems, and to change them is not easy, and not all homes are appropriate for changes to electrification, if indeed it was possible. But often what we do when we're talking about heat is we focus on the end user, but actually you have to look at the system. Does the grid that's supplying it, so the supply, demand, and then there's the grid. Does the grid, is it able to deal with the flexibility? Is there enough supply of a low carbon form of energy? And is the end user appropriate? Now, just to give you some examples from the H21 North of England report, that report looked at how you could convert all the gas networks in the north of England to hydrogen. It's set out in absolute detail. It's incredibly transparent. But just to give you some figures, so this includes Manchester, Liverpool, West Yorkshire, Hull, Middlesbrough, Newcastle. That's 3.7 million meter points homes, which is about 17% of domestic heat. And it's converting a gas network that is almost exclusively polyethylene that's fit for purpose for another 100 years or so. If you talk to the PE manufacturers, they say 400 to 600 years. And that network already provides this flexibility for heat. Now, actually, what you need to convert the north of England is 12.5 gigawatts of installed capacity, with a 9.7 gigawatt average. These are huge figures, 365 days a year. But in winter, on a winter peak, that's a 42 gigawatt peak demand. And that's when you absolutely need your energy. And that's when heat pumps and stuff obviously aren't as efficient, because it's the coldest part of the year. That's when you need the energy. So there's a reality, and the North of England system would also require 8 terawatt hours of interseasonal storage. Now, I know that there's energy balances in there and things, and we can do things to kind of smooth out the curve, but you can't eradicate it. So 8 terawatt hours is equivalent to 20 billion Tesla batteries, and you can do that in salt caverns at Aldbrough. So there is a reality with how the system works for how you decarbonise something like heat. And the other comment I make is that even if we end up with an amount of buildings that have electrification and district heating, and then some with hydrogen, which is probably where we are likely to end up, the scale and deployment of each will be debatable. Converting gas networks to hydrogen has another benefit, because what it does is it makes our hydrogen available at points of use everywhere. So if actually you want to hook hydrogen fueling stations up, you just hook them up to a hydrogen grid. So then alongside decarbonisation of vehicles with electric, you can also have hydrogen. So it's very complementary. It doesn't just have to stay on heat. So the use of the gas grid today can actually change to be maybe slightly different tomorrow, which again has a benefit on the curves. And the last thing I'd say on the decarbonisation of heat with hydrogen is that the safety case isn't yet in place. But there's lots of anecdotal evidence. So, for example, the first 150 years of the gas industry was based on town's gas, 50% hydrogen, and it's still used in Hong Kong today. So, there's a precedent there, and the H21 NIC project is just building some real test facilities at Spade Adam in Cumbria to prove actually that hydrogen represents a similar, if not lower risk, in terms of domestic heating than natural gas. So I think it's about using what we've got, being pragmatic about it, how we do it, understanding that supply and demand has to match. This isn't a simple, it's a flat curve. And basically using all the tools in the box to make sure that we can meet that net zero 2050 target, and actually the 2035 target, which I think is almost even more difficult.
So I suspect we could have a whole separate debate on this topic, Dan, and maybe we will at some point. Perhaps I could bring Mercedes into this discussion, because I guess one point I would throw in is whilst an individual consumer can decide if they want to have an EV or indeed install a heat pump, one thing they can't do is decide that they want to have a hydrogen boiler. And so therefore, at some point, government has to decide, do parts of the gas grid go to hydrogen? Does the entire gas grid go to hydrogen? How is that really going to play out when, even if it does go that way, consumers have the ability to decide whether they want to remain on that or not? So how would you think about this from a policy and from a government perspective in terms of how it makes that decision? Because that's a decision that if we're going to reach net zero by 2050 is going to have to be made during the next decade, I would suggest. So Mercedes, any perspectives on that?
Thanks, Nick. That's a very good question, and actually kind of picking up also from what Julia and Dan were saying on the previous question. I think we need to actually expand even that discussion a bit more, because I'm doing some work for the Jet Zero Council looking at decarbonizing the aviation sector. And there we also have the questions about, is that going to be through biomass, through hydrogen, what technologies, through some sort of a solid waste? So we really need to consider a very pragmatic approach, and Dan alluded to that as well, about where do we have this hydrogen and this biomass, and where is going to be the best way to deploy it. Because when you look at the projections from the Climate Change Committee, we are going to need to produce significant larger quantities of hydrogen than what we do now. And for the case of the UK, those quantities actually will even be of the magnitude of a global production of hydrogen in some cases, depending how you look at the numbers. So I think we need to look much more holistically than just what is needed for a sector, because there is going to be the heat, as it was discussed before, but equally I can see transport and aviation, they're also going to have their own requirements. And some sectors will have less options than others. So we are going to need to do at the government level. It's fantastic that we see all these policies that are going to come. We know that it's going to be the Treasury is going to publish their net zero review. There is the business models, the hydrogen models, the CCUS. So it's fantastic that we see all this coming. I think what we are lacking, there needs to be quite a lot of work about integrating all that at the national level, because when we talk about net zero is for the whole of the UK. And that means in very basic terms, there is no place to hide. So we're going to need to decarbonize every sector. And I think the conversation has to be integrated around all of the UK sectors. So I think it's a much more complex discussion that I don't think we have got there yet. I think we are taking a bit more of a sectorial approach, what is fine, because we need to understand what every sector needs and what the clusters need. But we need to make sure that's coordinated at the national level as well.
Well, and Mercedes, thanks. That's a great segue into my next question, which comes from Jason Collins-Webb, and it's about BECCS and direct air capture. And so I guess we've sort of talked about some of those technologies already today. Julia, you mentioned the direct air capture project that you're thinking about with Sizewell C. And we tend to think about these technologies as being sort of the offset for the remaining emissions that will be still part of the mix. So we need some negative to offset the positive emissions to create net zero. The question from Jason, as I read it, is really thinking, should there be more emphasis around these technologies, potentially to address some of the historical burden of the carbon emissions that the UK has emitted? So I guess, what Jason's really inferring there is, should we go beyond net zero and think about at some point in the future a net negative carbon emissions and the role that BECCS and direct air capture play in such a system? So Mercedes, maybe you can continue with that and then invite Julia maybe to contribute to that as well. Mercedes?
Sorry, I think I lost a little bit of connection there, Nick, what you were saying towards the end. Sorry.
So I guess the question really is, as we think about BECCS and direct air capture, we tend to think about them sort of providing the negative offset against the positive. So we're net zero. Should we think more about those technologies taking us into net negative territory?
So yeah, sorry, thank you, Nick. So we are gonna, I think it's clear that we are gonna need all these technologies. And one of my first slides, if you remember, it was all these different colors indicating that we need all the technologies. I think what we need to do is first make sure that we capture as much of those emissions as we can. And then whatever we cannot, then we will need to go through negative or direct air capture. So I think there is definitely going to be a space in there, and there is some space in there. I think the space maybe more looking, if you want, from a more holistically as well. I know that many organizations are looking in terms of getting their net zero plans and whether they do this through offsetting, when you should really be considering offsetting as well. I think that's maybe a debate for another day. But I think for us to reach net zero, and that was very clear also from the 6 carbon budget, we need to do negative emissions, so DAC or similar technologies. Again, this comes to what sectors and what opportunities and options are for each sector, and there are going to be some sectors where negative emissions or offsetting, if you're thinking, may be one of the few options that they have, and there are other sectors maybe where we can push them a bit more in terms of deploying other technologies, but it's a portfolio at the end of all of them. And maybe one final point as well, when it was a discussion also around public engagement. And I think what is really important is that we involve the public in co-creating these solutions. I think we need to kind of take the dial a little bit higher here in terms of just making sure that the public is with us from day one, that they feel like they are co-creating these solutions, that they are part of the solution. And actually there was a survey published probably about a year ago, but I don't think it has changed too much. And that survey was really quite revealing that the 78% of the UK adults want to be part and want to help the UK to reach net zero. So the appetite is there. It's not that we need to go around and twisting arms and minds, that this is something on the hearts and minds of people. We just need to make sure that we harness that and we bring them together with us from day one in co-creating those solutions.
Fantastic. Well, thank you, Mercedes. And Julia, from your perspective, direct air capture, something that could be scaled up alongside nuclear?
Yeah, no, definitely. I was thinking about this. There's a newspaper article which sort of does the rounds sometimes on LinkedIn, and it's from 1912, and it's a New Zealand newspaper. People have probably seen it, and otherwise, as I say, at the moment it's doing the rounds on LinkedIn about how the volume of coal being burnt is creating a blanket which is going to lead to temperature rises on the Earth. And so, just a sort of salutary reminder that where we've got to is something which humanity has known is coming for quite some time, and it's only now that we're really starting to address it. So absolutely, we think that if we were, for example, able to build another UK EPR up in Moorside, a lot more of it could be devoted to heat and to direct air capture. And just as an example of the power of the technology is that if you did that and you devoted your Grant nuclear power station to DAG, then you would actually offset all of the emissions from the UK's pre-pandemic aviation industry. So it has huge power. And of course, to the questioner's point, as the aviation industry decarbonises anyway, and hopefully finds ways to use synthetic fuels and/or moves over to electricity, then absolutely we would be not only offsetting the existing emissions, but we would be moving into net negative territory. And I think as the country which sparked the Industrial Revolution, it is a good thing if we can actually show leadership in the way out of it.
Absolutely. And building on that, Julia, a question from Harry Cripps to you around the assessment of the embedded emissions in a project like Sizewell C. So, all of the emissions that go into the construction, the equipment, and anything else associated with that. You mentioned some carbon emission intensity figures at the start around grams per kilowatt hour. How do you think about the life cycle emissions from a project like that?
So it's something that we get asked quite a lot, because obviously it is a large construction project. So as I said, we have asked an environmental consultancy, Ricardo, and to undertake what's called an environmental product declaration. It's very granular. It looks at where are we buying our steel from, what's the embedded carbon in the steel, how's the steel getting to the site, how many litres of diesel will we burn, as obviously we're going to try to minimise our use of diesel by moving to hydrogen and electricity, and so on. It's very granular, and that assessment, which is done by Ricardo, is then verified by WSP. So it's quite robust, and it does come out at 6 grams, and it means that once the power station is turned on, the construction emissions will be offset within 4 to 5 months of turning the power station on, and the power station will run for at least 60 years. So we're confident it's robustly a very, very low carbon way of making electricity. But of course, until all these other sectors are able to decarbonise, we can't, any of us, whatever we're building, take the carbon out of construction, because what we need is, as we've been, Mercedes and Dan have both been discussing, we need to collectively be taking the carbon out of steel production, etc., in order to avoid this issue. And this issue isn't particular to nuclear. This issue is endemic in building anything.
And just to clarify, Julia, I mean, you mentioned that those emissions are offset in that short time period. Is that actually offset, or is it the low carbon power you've generated and the delta between what the grid would otherwise be drawing? Because
you're quite right, Nick. You're quite right. It's if you, given that we need huge amounts of electricity and indeed heat, if you were to make that heat by burning gas through a CCGT, then you would emit an awful lot of carbon, and this within 4 to 5 months offsets the content of the bill.
And I raised that question not to be pernickety, but I think it's an interesting point, and it came up recently around Brookfield and their sort of assessment around how you think about the offsetting, but clearly with technologies like direct air capture and BECCS, there actually is the opportunity to reach truly through time zero life cycle carbon emissions. So I'd like to talk a bit about sort of the international opportunities, and Julia and Dan, you both sit on companies which have global investments. Your boards look at opportunities around the world. Maybe start with Dan. Could you talk more about, firstly, how Equinor think about their deployments of capital into opportunities in low carbon sort of cluster type technology, and how the UK sort of ranks? Where else in the world is thinking about projects like this? Where does the UK rank attractively? Where are the sort of areas where others may rank more attractively, if you like, Dan?
Yeah, I mean, I think obviously Equinor have projects all over the world. I mentioned the wind farm off New York in my presentation, but we have a corporate commitment to be net zero ourselves by 2050. So, Equinor is very keen or very committed rather to low carbon projects. I think the way we see it is that Europe is really leading the way in terms of low carbon emissions. But as I said earlier, I think that the UK political landscape, in terms of its acceptance of CCF, CCS, its agnostic position to blue and green, it is really advantageous for the UK. And you can kind of see the movements in Europe towards that position, as indeed everyone realises the requirements, the realities of what needs to happen to get to net zero and to make big impacts quickly. And obviously, there are a lot of our, they're on our doorstep, aren't they? So, we're Norway based. So, but I do think that Europe really will lead the way for the rest of the world in terms of decarbonisation projects. And I suppose to the question earlier around should the UK get more negative to offset global emissions, it's realistically, I don't agree with that comment. The reality is, in 1990, the UK was emitting 800 million tonnes plus of CO2 every year. And it's obviously got one of the biggest historic pollutions. But actually, leading the way in decarbonisation technologies, climate change isn't a UK problem. It's a global problem. And what they need to do is, I think that the more probably wealthy nations, certainly the UK with its advanced policies in Europe, needs to deploy these technologies so the rest of the world can effectively copy them and deploy them themselves. I think it's 1% now of UK emissions. So actually showcasing the technologies, showing how they work, developing the business models, driving down the costs in the UK is the best way to actually support global ambitions, because then other companies, including the developing nations, can copy. So I suppose a bit of a more answer, but hopefully that fixes the box.
Thanks, Dan. And Julia, how do EDF think about the UK in terms of its global portfolio?
Well, so as people who are regular studiers of electricity map will know, France has one of the lowest carbon electricity systems because of the choice to deploy a mix of hydro and nuclear, and then now increasingly plus wind. And so EDF has made a huge contribution to showing how it is that one can run an industrialised economy with a very low carbon power system. With EDF in the UK, EDF is obviously investing huge amounts of money into Hinkley Point C. As you said, Nick, hopefully people have seen some of the documentary and the extraordinary engineering work that's going on there. And so EDF's putting sort of at least 14 billion through the UK economy, upskilling the UK construction workforce to build new nuclear for the future. With Sizewell C, EDF is looking to be a minority shareholder, and so we are expecting the government to introduce a regulated asset-based model which will put nuclear onto a footing where it can be invested in by financial investors, pension funds, etc. And I think that is a great step, because what we want to do is to enable the country to right size the amount of low carbon infrastructure that it needs. And so once the model is investable, then progress can be driven by need of the electricity system, and rather than reliant on utilities balance sheets.
Great, thank you, Julia. I'll go back to you, Dan. So we've got two more questions. So one, we haven't focused too much on oil and gas, so I just want to sort of bring in a question from Mohammed Madni, who's asked, how do you see the local regime in the UK and in other areas where Equinor is operating developing over the next 5 years to help the E&P sector, the exploration and production sector, transforming towards sustainability? So a quite open question there. If you could give us a short answer, that would be helpful, please, Dan.
Not sure I fully understand the question there, but I think I mean, obviously we still need gas and oil. You know, there's a transition, so obviously we're not going to stop tomorrow because the world needs energy, and so it's about enabling that transition quickly. I think the interesting thing that when you look at actually at scale low carbon technologies such as CCS, what you need is a transfer of those skills into the CCS space and actually the hydrogen production space over time to enable that transition. You know, if you look at the Northern Endurance Partnership scheme that I showed in the presentation, that's 5 of the world's biggest oil and gas companies deploying their offshore expertise to make sure these things can actually be developed. You know, you can't just have a go at offshore. You need to know what you're doing. So I think that there's a redeployment of the skills in terms of the benefit that can bring to deploying these low carbon schemes. But obviously in the short term, there is still a demand for energy, and obviously companies are trying to fill that demand whilst actually being cognizant of the obligations to decarbonise. So it's a fine balancing act, and a lot of it's driven by policy.
Thank you, and it's great to see that capability transferring across, and clearly, the oil and gas sector has a huge amount to bring into areas not just CCUS and hydrogen, but also areas such as offshore wind, as we've seen play out through what Equinor and others have been doing, Dan. So, final question, and we may have a bit of fun with this. So, I mean, we've and Mercedes, you talked at the start about the sort of long list of projects that are going on in the UK that are being assessed. Dan and Julie, you both made sort of little pitches for the fantastic projects that your companies are engaged with, and there were many names of different companies and different projects on that list. And whilst ultimately all of these projects are trying to achieve the same thing, driving towards net zero, there is clearly an element of competition and also of sequencing. So maybe I could throw the question to Mercedes, and then we'll hear from each of Julia and Dan. What role does government have in sort of choreographing the sequencing of all those projects? And how should we think about competition? And is it feasible that all of those projects will actually go ahead? So Mercedes, perhaps you can lead us into that.
Thank you, Nick. So yes, that's quite a very good question to end up today's debate. So Dan already described the sequencing that is happening within the clusters. I think at the end of the day, what we need to realize is that public money is not going to decarbonize the UK. It's not going to get us to net zero. I think that it's going to have to be a private investment. And what we need to make sure is that we set the right policies that actually bring investors and drive them here. And that's going to be policies that provide the stability on the medium and the long term for those investments to come. Now, what the government is putting forward is a series of business models, and obviously that's going to some extent shape what those potential investments or what the markets may look like. And that's something also that we need to consider. But I think ultimately what we need to be clear is that public investment is not going to get us to net zero. We need to make sure that there is, and we attract, and as I said in my presentation, if we really get this right, actually we're going to be attracting investment to the UK. We talked before about the supply chains and opportunities for export as well. So really, how do we bring all that together? And how do we make the UK, is what I like to say sometimes in my presentations. What I really would like to be able to say is that we are shaping the clusters of tomorrow. You know, how this transition is going to happen, but how we're actually shaping them to actually get them not just to decarbonize, but really bring them as centers of world-class centers, really, in terms of decarbonization.
Thanks, Mercedes. Julia.
I agree with Mercedes. I think it's really important that we arrive at investable models for all of these technologies to come forward. There's a lot of money which is potentially investable by pension funds domestically and internationally by other financial investors, and we just need to make sure that as much of it as possible can be attracted into the UK and to help bring forward all of these technologies. So yes, there is a degree of competition and some things are run competitively, but broadly speaking, as I said before, we need everybody to succeed.
Thanks, Julia. And Dan, final word on this topic. Will all those projects go ahead, do you think?
Yeah, I mean, well, I suppose the simple answer to that is they must if we're going to meet our targets. So if we're not going to meet the targets, then the projects won't go ahead, or we'll shut everything down. But realistically, to meet the net zero target, all the projects must go ahead. So the question is really, when will they go ahead and how quickly, I think is the more appropriate question. I think in my view, when you're looking at the cluster sequencing process, etc., what we have to do is make sure we get the first projects right and get the scale right. And I think to do that, you need the companies that are the most credible companies. They have the experience of these mega scale projects. They have the balance sheet. They have the appetite and the drivers to actually pull these projects off. And I think that the great thing between this kind of Humber cluster, the Humber is the most diverse market you can see with the biggest scale, and it's got big companies who are investing millions to deploy these technologies. And the aim should really be, in my opinion, is to make sure you have a low regret start where it's companies who can actually deliver, you can get the scale, you can showcase a range of technologies, and then what we can do is deploy all the other projects quicker, safer and cheaper, because they can learn from the experience of the companies who actually deliver the first projects, and you can drive down the costs through the economies of scale. So I think getting those 1 or 2 years isn't really the driver. I think the driver is making sure them first projects deliver, the diverse, and they allow others to learn from them, not just in the UK, but globally.
Absolutely. Thank you, Dan. Well, we're coming to the end. I'm just going to ask each of our panelists to just give us a few final comments. If I could just ask for a minute from each of you, and just sort of highlighting any sort of parting thoughts, or if you wish, topics that we haven't raised today, just very briefly. And so if I can throw it over to Mercedes, and then Julia, and then Dan, just to finish with some final comments before I conclude and wrap us up before 1 o'clock.
I think in terms of maybe the concluding comment that I may add here is, I mean, we did talk about the role of innovation. I think it's clear that innovation is taking us out of the COVID crisis when we think about the vaccines and how quickly we have been able to do it. So although we are not out there yet completely, but I think it's really innovation is going to be critical as well in terms of the climate crisis. I think it's a point about innovation here around integration, around scales, around the business models, the regulatory framework. How do we really get solutions? I think really this is what is needed. And I think that will really be my parting comment, really, is innovation can take us out of the COVID crisis, is doing it, and it will do it for the climate crisis as well.
Great point. Thank you, Mercedes. Julia.
Thanks, Nick. I think I'd just like to emphasise again how important it is to think through how technologies and sectors can work together for the best outcome for consumers, remembering that all of this is about people. And then the topic which we haven't really covered, and I think is really important for all of us to bear in mind, is biodiversity. And that alongside addressing carbon emissions, we also need to address issues like use of land, having room for nature, and making sure that all of us across all of our businesses start to focus more on maintaining biodiversity and encouraging it at an individual and a corporate level.
Absolutely, and perhaps something there for a future conversation, Julia.
Yeah.
Thank you. And Dan, finally.
Well, I think what's key is that, you know, a lot of the low-hanging fruit has been picked, so to speak, in the UK, and really to make tangible impacts now, we really need to do some of the big projects. We need big decisions, and we need to build the infrastructure, because without the infrastructure, most of the project ambitions just can't be realised, whether that's negative emissions through PECs, whether that's the hydrogen economy at scale, whether that's decarbonising steel. You know, the fact is we need to build the infrastructure, and we need to do it quickly. So I think that's probably one point. I think the other point is that we need to do it where we've got a diverse range of projects so that we can deploy them and learn across the UK, but also impact across the world, because often we do talk about the UK's target, but the UK's target only makes a tangible impact on climate change if actually the world adopts a lot of the technologies and replicates. You know, with different technologies at different scales in different areas based on the geography, geology, etc. But I think it is a global issue, and I think for the UK, in terms of this global UK brand, the levelling up agenda, the post-COVID recovery, etc., and indeed position itself at the forefront of the green products market, the first mover always gets the biggest advantage. So it's a great position, but we just need to push on and get these first projects going.
Absolutely, and I fully support that view, and I think there's a tremendous opportunity for the UK to really play a much broader role globally in this space, and we've seen it in areas like offshore wind and indeed oil and gas before that. So exciting times ahead. So that draws us to the end of today's session. I guess very briefly to wrap up, I've picked up sort of 4 big themes as we've gone through today, and the first of those is really around the importance of alignment of innovation. We heard that word a lot today: innovation, technology, business models, financing, policy, and the regulatory structure. You need to have all of those together and in order to scale up, and that's come through loud and clear, and a lot of the thinking seemed to resonate around that. We talked a bit about the start around the sort of convergence of electrons and molecules, and that's really come through loud and clear. But also, I would add neutrons, and I certainly will think about nuclear differently with the combination of direct air capture and the use of all that heat. And so really, this is a convergence of all forms of energy coming together. And I think all too often the energy industry is sort of portrayed as sort of fragmented and diverging. I think the exact opposite is happening. We are converging, and the more we can integrate and have a systems view across all those different things working together, the more likely we are to solve the problem. There's been a big theme about working together. Julia, you talked a lot about that. Dan, you talked about that, and Mercedes, you talked about all the different collaboration you're doing, and bringing together industry, government, academia, groups like the Energy Institute, and of course the public is going to be absolutely critical in delivering this. And that last point around the public, I think the fourth point is community. And all too often, I think the energy industry sometimes sort of thinks about the community last, and having community engagement up front, involving the public, and particularly in something that they have huge appetite for, can only be a good thing. There's a huge opportunity to really engage the public. So with that, I would like to thank our panel, Professor Mercedes Maroto-Valer, Julia Pike, and Dan Sadler. Thank all of you for joining in today. We've enjoyed the questions. I hope you found a useful session. To find more about the Energy Institute, please go to our website and follow us on LinkedIn and Twitter. And finally, would welcome any feedback. So if there are things we can do differently, better, ideas for new topics, please do let us know. So with that, wish you all a very good rest of the day, and thank you so much for joining. Goodbye.